Product from Packet, and he's going to share with us his insight into innovative hardware. Please join me in welcoming Aaron.
Hello, everyone. So thanks for having me. We're excited to be here. So yeah, let's imagine what the internet is going to be like in 10 years. But first, who the hell am I? I co-founded Packet in 2014. I initially directed the product development and architecture there, and now I work primarily on open source and partner integrations. And I still lay down code, mostly Python and Go. I've written several of our integrations, like our Terraform drivers and libcloud integration and various other ecosystem drivers. In a previous life before Packet, I was a political tech junkie. I worked on 2 failed presidential campaigns. I was a hardware hacker, web developer, systems administrator. I've been running various distributions of Linux for quite a while now, and we're going to have a little bit of a retrospective of the last 10 years. So I thought this was an interesting sort of point. I bought my first stick of RAM, which is a 4 megabyte stick, for $144 in 1995. So what's Packet? We're relatively new on the scene, but we're basically a bare metal cloud platform. So it's a fully dedicated servers on demand over an API. We're backed by SoftBank and Dell. We have 11,000 users from SaaS startups to Fortune 50s. We have 50 locations globally. And we do about 50,000 deploys a month, all taking place in less than 8 minutes. So that's a fully bare metal server, no hypervisor, no virtualization, full provision lifecycle in about 8 minutes. And we offer both x86 and ARM v8 servers by the hour. You can deploy them in 4 different ways. We do it on demand, which is our public cloud. You can just go sign up there today and do it. We have reserved instances, we have a spot market, and we also do private deployments. So fundamentally, it's hardware at the end of an API. And we started Packet because we had a deep passion about the physical infrastructure behind the internet. We believe in the disruptive power of software and open source. And we think that software is eating its way down the infrastructure stack a little bit counterintuitively than most people feel, but we felt like, especially with the rapid adoption of containers in the broader software development community, that was bringing a level of portability that the cloud had always sort of promised, but was never really delivered on, especially with the big virtual public clouds out there. So we focus on automating fundamental infrastructure, and we bring that automation with as few opinions as possible. So no hypervisor, no virtualization, no co-tenancy, just the bare bones. You're obviously free to bring your own hypervisor and do whatever you want from there. So this is fundamentally what we set out to do, was to build a better internet. And so that sort of leads us to the question, what will the infrastructure of tomorrow look like? But first, predicting the future is really hard. We don't really know in 5 or 10 years. Will it be the same? Will it be different? And so to give us a fighting chance, we're going to go back to the future about 10 years ago and give you a little rundown. So the iPhone was 2 months old 10 years ago. Pretty much everyone was on BlackBerry. I was slinging this guy. AWS was just 18 months old. So the EBS hadn't launched yet. This was a time when, really, this was one of the first times that software engineers could just get a VM more or less instantly. And when they launched it, AWS engineers still considered this essentially utility and weren't even thinking about using persistent storage yet. So this was like groundbreaking new stuff and somewhat confusing, honestly, to a lot of traditional web developers. Luckily, a lot of things stay the same. This is what Reddit literally looked like in 2007, which is pretty awesome. Some things are no longer with us. Yeah, there was no Uber. So Uber was still 2 years away, and in the initial presentation of the day, you saw that other long list of things that didn't exist. So it's pretty crazy how far we've come in 10 years. So what's next? In our opinion, the infrastructure of tomorrow will be defined by specialization. The change is going to continue to accelerate. It's going to be even more rapid than the last 10 years. The velocity of software is going to be the main driver of that. The number of software developers working is growing faster and faster, and they are just pounding out a lot of code. And hardware is going to be the next innovation layer because of that. But the only way that that's going to happen is if we're able to get the hardware in the hands of those developers. So I think we're going to see that faster adoption in the next 10 years, mainly being fueled by that software development. And this is one of the reasons that we founded a bare metal cloud in 2014, when essentially, in many people's minds, the cloud war had been won. Is that software is hitting the limits of the virtual public clouds. People grapple with expensive compute that is inflexible, it's inconsistent, and they're doing a lot of acrobatics on the software side to kind of deal with that. And as we get to, sort of Moore's law limit on thread speed, people are already looking at how to offload specific workloads. You see people looking for GPUs in the cloud. You see people looking for SSL offload in their network cards. So I think we're going to see a shift from abstract compute and blobby resources in the cloud are good enough to I really need to start to target my application workloads to specific hardware. And I think that there are three areas that are going to be particularly dependent on specialized hardware. I think virtual reality and gaming is one that we're already seeing without question. Internet of Things is still a wild, wild west. There's not a whole lot of best practices there, and the demands and requirements there are so much different than what the cloud generally gives you out of the box. And autonomous hardware, driving cars, drones, your refrigerator may deliver beer to you in the middle of the night, who knows? And so let me give you an analogy, right? So in 10 years, if there's 25,000 self-driving cars in New York City, the software that's driving those cars is not going to be in Virginia for a variety of reasons. Latency is going to be an issue. Regulations likely will affect that. Efficiency and power, security, and so you're going to see hardware that needs to be specialized and local, which currently doesn't exist. So as I said, rapidly Moore's law isn't becoming the most important metric that we're going to measure things by. Workloads have become much more efficient and portable. Again, especially with containers, now you have the ability to truly be multi-cloud. You can deploy on specialized hardware in your on-site data center, on-premise, while also deploying other workload to multiple different cloud providers. And we're seeing that on Packet. We have a lot of people that are deploying very specific workload for their application on our dedicated bare metal, while then delivering various payload to the entire Amazon ecosystem. So this is the direction that the entire, basically, I would say, at scale cloud workload is going. And especially with microservices and now hosted serverless Lambda functions, the ability to target very, very specific pieces of your application and workload of your application to a very, very specific piece of hardware, location, profile is now possible where it wasn't possible before. So we need to think about developing the next wave of infrastructure innovation a little bit differently than the last. So AWS and the virtualized public cloud was, in my opinion, the last sort of innovation. It provided infrastructure on demand, easily at the fingertips of an entire generation of software developers. The next generation of software developers is going to have to get closer to the hardware. So there's 6 words that I would describe, and we kind of talk about at Packet, as being that next generation of infrastructure, specifically as it relates to the cloud and the internet. So it's automated. It's fully automated. One of the biggest differentiators between us and a traditional dedicated rack and stack web host is that you can hit an API and get a server in a few minutes. And that's table stakes now for modern web development and application developers. If it doesn't work with Ansible, if it doesn't work with Terraform, if I can't get an API library and hit an API and get the resources that I need and fully program against it, it's not viable. It needs to be distributed. This, may be obvious to some, but I think there will always be a place for these sort of mega data centers and sort of gigantic regions in one specific place. But especially latency applications with low latency requirements and the like need to have more compute out at the edge. So we've done a good job at distributing edge content, but that's not the same as compute on the edge. Again, it's specialized. So I think you're going to see more and more people that are utilizing specific offloads in the hardware itself. So SSL offload in network cards to GPUs to TPM chips. As these workloads become more specialized, people are going to be looking at targeting specific workload to specific architectures. And the infrastructure needs to be primarily agnostic. So you can't assume that you're going to bring a hypervisor. You can't assume you're going to have network attached storage. You can't assume that the hardware only works in specific conditions. And we're seeing this a lot where because people are going to be bringing their own, right? People and software developers are more and more assuming that they can orchestrate and bring their own virtualization or their own bare metal or whatever it is, and if there's a bunch of stuff in the way, then they're not going to use it. And a lot of it's going to be untrusted, so you will likely be taking advantage of cloud resources and hardware that are in places that don't have a retina scanner and a man cage. You may be deploying compute and workload out into edge sites that you don't trust. So a lot of that infrastructure is going to be untrusted, and so that is a problem I think that the software engineers are going to have to figure out how to securely and safely use these untrusted resources. And it's really going to be dynamic. Like the infrastructure is going to have to get more dynamic. I think the days of dropping, a hardware appliance in your data center are going away. We have, like I said, an entire generation of web developers and engineers who have grown up in a totally dynamic environment, and that have actually very little concept of what actually is happening back there. By back there, I mean in the data center. A lot of them haven't looked at a server. They don't know what it looks like. They haven't even cracked open their laptops. So this is, I think, what generally describes what we're going to see in this sort of next generation of infrastructure on the internet. So it sounds great, right? What could possibly stop us? It's a good question. And the answer is access and adoption. In my opinion, the only thing that's going to prevent this sort of next infrastructure disruption in the market are these two things. And the challenges with that is infrastructure is hard. It's hard to build. It takes a long time. Dealing with the real world is difficult. And access to big hardware is rare. And by access to big hardware, I mean enterprise-grade ARM chips. And the people I'm talking about giving access to are those hundreds of thousands of people on GitHub that truly don't understand the hardware. They're used to dealing with abstract blobs of compute. A lot of these folks don't even understand that a Raspberry Pi is a different architecture. Right? I mean, this is kind of like, but this is a community that's driving all of the fundamental software that runs, 90% of the internet. And yeah, most developers have never touched a server, a GPU. They don't understand that ARM is an architecture at all, or that Intel is one. We have a gap there in terms of education and understanding. And a lot like, yeah, you can't change your oil in your car anymore. well, electric cars don't have oil anymore. You don't crack open your phone, you don't really crack open your laptop. Desktops are even going away. So the number of developers who have built their own PCs, for example, that number is getting fewer and fewer. And honestly, multi-architecture support is pretty poor in the broader software ecosystem. Compatibility is, is its problem. And as long as that foundational software doesn't just work, CIOs and CTOs are not going to invest in even looking at or doing a POC on a different architecture than x86. And that's too bad. And yeah, so no sane person is going to do CI/CD or much less production on a Raspberry Pi. It's basically a toy in that context. So what should we do about it? So in short, let's make firmware cool again. There you go, right? We have to find a way to ignite that spark and that interest in this sort of generation of coders. To show them that it is cool, it's fun, it's awesome, it's why I am doing what I'm doing. But they've been pushed so far away from it by the general trends that they just don't know what they're missing, quite frankly. So it's not all bad news in reality. In fact, the interest in hardware is growing. Raspberry Pis, the Internet of Things wave. When I look back to, when I was wire wrapping shift registers to now, the ecosystem in terms of embedded devices and platforms, from BeagleBone to Arduino to, there's more, it seems like, coming out every other day. The Onion, and then the Raspberry Pi, people love it. They just love it. If you look at all of the really interesting and fun projects that people are picking up that are just average coders that are able to get into a full Linux environment with Wi-Fi on an embedded device is pretty cool. So that's good. I think people are interested in it. There's just a long learning curve for a Python developer to learn how to program C. And we're already making good progress. So Packet works with ARM on the Works on ARM program. Ed Villamenti over here runs that program for us. He's going to be talking a little later in the day. I asked him today for a good statistic, but since Docker released multi-architecture support, about 33% of the top 140 Docker projects supported ARM in about 3 weeks. Yeah? And now basically, the Go programming language, which drives most, I would say, microservices nowadays, is essentially fully supports multi-architecture. So it's pretty easy now, if you have written something in Go, to have it work on ARM without too much porting pain. So that's great. But we can do better. And really, in my opinion, and this is why I primarily at Packet focus on community outreach and partner integrations, because I really believe that you have to bridge that gap between the hardware communities and that broader software community. And you have to find a way to, excite that millennial developer, to give them an opportunity to touch the hardware, to play with it, to understand the power of it, and finding ways to get enterprise-grade hardware and architecture other than x86 in their hands. We launched with ARM and with a little bit of SoftBank's help, the first enterprise-grade Cavium ThunderX chip on our cloud last October. And that was, it was awesome. That was I think that was basically the first time that you could, on demand, in a few minutes, sign up on a website and get, it's a 96-core box, 2 Cavium ThunderX chips in that box. And the response from the software community was just incredible. We had people coming from every project you can imagine, from kernel developers, Linux distributions, to Node.js developers, who are like, finally now I have an automated way to get access to ARM. So now I can plug it into my CI/CD. Now I can get it into my production pipeline. So that was pretty fun. But Cavium is just one in a much bigger ecosystem, and I think we need to do a better job. And we've been working with Qualcomm as well, and getting their new board out to market as well. So that's good, but we can do better. And the other piece that is maybe not so much on the radar, but we would like it to be, is the more that the hardware provides metadata about itself and what it's doing to orchestration software like Kubernetes, the faster this adoption is going to go. Because truly, these new orchestration platforms and this new orchestration software, while still relatively new, puts a level of power and ability to consume infrastructure in the hands of developers unlike anything we have ever seen. I mean, they accidentally spend a lot of money, a lot of time, by having Kubernetes go nuts. But that's ultimately the tool they're going to use. So when I say that when you start to pick apart your application and you start targeting particular workload within your application to specific pieces of hardware in specific locations for specific reasons, that metadata that the hardware provides is what's going to enable you to do that. Because you have to have that context in order for the software to be able to do that. So here's just some examples of things that the software is going to want to know about in order to properly orchestrate workload and microservices and Lambda functions for software developers that are working in these multi-architecture environments. So we invite you to join us. We work with a lot of you already. I'd love to meet you if we haven't and you would like to come along for the ride. And we have a little bit of an exciting announcement, so get ready. We're actually putting together an event November 29th and 30th in Las Vegas, which occurs at the same time as another big conference hosted by another big cloud provider, actually right in the middle of their campus, which will give us an opportunity to hopefully educate a lot of the developers that are going to be there for that conference about the culture, the craft, and the excitement of infrastructure. And so we're hoping that as many of you as can will join us there. There's a little bit of a teaser at ifxproject.org, and that's that. So I'm Welch at packet.net if you have any questions, and I guess if we have time, I'm happy to answer some here as well.
Thank you so much, Aaron. We really appreciate you coming here and sharing that with us today. I think we're just